We've been given a random root function, but we've identified the critical points or the reference points. So they're all in this table here. And the translated function is written over here. Now again, it's important to differentiate the outside transformation, which is y, from the inside transformation. So I'm going to look at my outside transformation. There's only two things happening. Outside the f, there's a times by 1/2 and a plus 1. So the changes in y, so I'm going to write this way, the changes in y is going to be compression by 2, or compression by 1/2, and then we're going to shift it up 1. So we take every one of these y coordinates, and the nice thing about y's is we don't have to undo anything. It's directly how it's written. We're going to times by 1/2 and add 1. So we're going to end up with 3.5. Okay, we're going to times by 1/2. It's going to be negative 1.5. So we end up with negative 0.5, negative 0.5. That's going to be 1.5 plus 1, which is 2.5. And then 2.5 plus 1 is going to be 3.5, like our first point. So that represents all the vertical transformations that occurred here. We then look on the inside for the horizontal or x transformations. Now some of you may have a shortcut to this, and that's okay to use, but essentially we have a horizontal expansion and a flip and a shift to the left too. And to keep track of this, we really want to have a concise process. And so I'm going to do it this way. So my change in x is going to be like this. This is my notation, negative 1/2 x plus 2, and this happens to get me back to the old x. Now, whether you keep track of this or not, it doesn't matter. I want to undo all these transformations, and I can undo by solving. So I'm going to undo this, times by negative 1/2 by times by negative 2. Sorry, divide by negative 1/2 by times by negative 2. I'm going to undo the plus 2 with a minus 2. So I've done the exact opposite, and not only that, I've done it in the opposite order. And that means I have the correct description of the transformation. And this is how it's going to happen. It's going to go expand and flip, and then shift to the left. Okay, and that's the order that it happens. So I can use that expression now to transform my coordinates. I have negative 2 times negative 8 times negative 2 is positive 16, minus 2 gives me positive 14. I get 0 times negative 2 minus 2. Negative 2 times positive 3 is negative 6, minus 2 is negative 8. Negative 8, and then I get negative 2 times 8 is negative 16, minus 2 is negative 18. So those then represent the new coordinates. Now it's going to be hard to draw this, but I'm going to attempt the best I can to draw this. So this horizontal expansion is really going to make it difficult, but if I want to describe the change in an x, then I use this here, not the notation. So it's going to be, the first thing is, well, I can just write it like this. My new x's are going to be a flip, expansion, shift left. So horizontal flip, expansion by 2, so it's a horizontal, and then lastly horizontal shift left 2. And so graphing these new coordinates, then the new graph is going to look like this. So it's going to be 14, so 3, 6, 8. Oh, this is going to be hard to draw. So I'm going to scale my axes here. So it's going to be 7 here, 3.5 is somewhere up here. So I'm scaling my x, but I'm just going to keep my y the same. Negative 2, negative 0.5 is somewhere here. Negative 8, so negative 8, negative 0.5. Negative 8, 2.5. Negative 18, and 3.5 is right about here. Okay, so it's going to be this graph that looks like this, like that, and like that. Okay, so that's going to be the transformation of those coordinates. Okay, so the original coordinates here in black into these new coordinates. So we can see there's a horizontal flip going on. There's some expansion. The expansion is hard to see because I've kind of scaled it the same as the original graph.